Good morning, sir. My name is Yal Monica. I am from second year ECK section. Today, I would like to explain about operating points and DC load lines. The outline of this topic is Introduction to Operating Points, Definition of DC load line, Importance of Operating Points, Characteristic curves, Example of a DC load line, Operating points in amplifiers, biasing techniques, stability of operating points, intersection of load line and characteristics. Introduction to operating points. Operating points are critical in defining the behavior of electronic circuit. They represent the specific condition under which a circuit operates. Understanding operating points help in analyzing circuit performance and stability. Definition of a DC load line. A DC load line is a graphical representation of the relationship between voltage and current in a circuit. It is constructed based on the circuit's power supply and load resistance. The load line helps visualize the operating point of a device in a circuit. The straight line is known as the DC load line. Its significance is that regardless of the behavior of the transistor, the collector of the behavior, collector current IC and the collector emitter voltage VCE must always lies on the load line. Depends only on the VCC, RC and RA. Importance of operating points. Operating points determines the linearity and efficiency of the amplifier. They influence the overall performance of the electronic device and systems. Identifying the correct operating point is essential for optimal circuit functions. If the operating point is in forward bias, then it gives effective outputs. How to determine operating points? To find an operating point, analyze the circuit's characteristics and constraints. Use the intersection of the load line and the device characteristic curves. The intersection points indicates the circuit's steady state operation conditions. Characteristic curves. Characteristic curves illustrate the relationship between voltage and current for a device. These curves provide insight into how a device behaves under different operating conditions. They are essential for determining the operating point in conjunction with the load line. It is a relationship between voltage and current in a forward bias diode. VI characteristics of forward bias diode. Drawing a DC load line. To draw a DC load line, plot the maximum voltage and current values of the circuit. Connect these points with a straight line on the voltage graph. The slope of the load line is determined by the load resistance in the circuit. Example of a DC load line. Consider a circuit with a 10 volts power supply and a load resistor of 1 kilo ohm. The maximum current drawn would be 10 milliamps and the load line can be plotted accordingly. This graphical representation aids in determining the operational conditions of the circuits. Operating points in amplifiers. In amplifiers, the operating point must be set to maximum linearity. A proper operating point minimizes distortions and enhances signal fidelity. Adjust the operating point can optimize amplifier performance for specific applications. Effects of changing operating point. Changing the operating point can lead to altered circuit behavior. It may result in increased distortion or reduced gain in amplifiers. Understanding these changes is crucial for circuit design and troubleshooting. It is must the operating point should be in middle, that is forward bias. If the operating point goes to saturation region, it distortions less, it doesn't get distortion less output. If the operating point moves to cutoff region, it also gives the distortion output. Biasing techniques. Biasing is the method used to set the operating point of a transistor. Different biasing techniques can stabilize the operating point against variations. Common methods include fixed bias, voltage divider bias, and emitter bias. Out of these, Fixed bias is the best to operate the operating point in a forward bias. Stability of operating points. Stability refers to the operating point's resistance to change due to external factors. A stable operating point is less sensitive to variations in temperature or component values. Stability is vital for reliable circuit operations in real-world applications. Stability pattern indicating stable operating points and unstable operating points with the parameters in this graph diagram. Load line analysis. Load line analysis involves examining the intersection points of the load line and the characteristic curves. This analysis reveals the maximum power transfer conditions and efficiency. It is a powerful tool for evaluating circuit performance under varying loads. Graphical representation. The graphical representation of a DC load line simplifies complex circuit behaviors. It allows for quick assessments of circuit performance at different operating points. Engineers commonly use this method for design and analysis purpose. Intersection of load line and characteristics. The intersection point indicates the actual operating point of the circuit. Moving the point affects the current and voltage the device. Understanding this relationship is key to optimizing circuit functionality. X-axis we can take as VCE in volts. In Y-axis we can take as IC in milliamps. Challenges in finding operating points. Finding the optimal operating point can be challenging due to non-ideal components. Variations in temperature and supply voltage can shift the operating point, uh, move to saturation region or move to cutoff region. Careful analysis and robust design and can mitigate these challenges. Applications of load line analysis. Load line analysis is widely used in designing amplifiers and oscillators. It helps engineers ensure that circuits operate efficiently within their intended ranges. This analysis is crucial for both analog and digital circuit design. If the operating point is in forward bias, then it gives a perfect output and efficiently. If the operating point moves towards saturation, it gives distortion outputs. Summary of key concepts. Operating points and DC load lines are fundamental concepts in electronics. They provide insight into circuit behavior and performance. Understanding these concepts is essential for effective circuit design and analysis. Further readings and resources. For more in-depth knowledge, consider textbooks on circuit design and analysis. Online resources such as tutorials and videos can reinforce these concepts. Engaging in practical experiments can enhance your understanding of operating points. Thank you.